Okay, so let's take a look at these pure maths past paper differential equation questions. Question 1. The value v of a car may be modelled as a continuous variable. At time t years, the rate of decrease is directly proportional to v squared. Write down a differential equation satisfied by v. Okay, so one of the critical things there is that we're talking about a decreasing proportionality. It's not inverse, so it isn't going to be 1 over v squared, but it's going to be negative. So the rate of decrease of v, so rate of decrease will be dv dt, and because it's a decrease, okay, so decrease means that's negative, and the proportionality means that it's going to be proportional to minus v squared. Don't like the proportional symbol, we haven't got any maths we can do with it, so we replace it with a constant. So dv dt equals minus kv squared. That's your differential equation. B. Given that v is 12,000 when t equals 0, show that, so there we got an expression there, which means we need to solve that differential equation. We can only do it by separating variables. So if I bring the v squared over, it becomes 1 over, and if I leave the minus k where it is, I'm going to have that. This isn't natural log because it's a power that we've got over there. So if we write that in index form to perform the integration, we add 1 to the power, divide by that, so we get v to the minus 1 over minus 1 equals minus kt plus the constant c. So what do we know? Let's go back. When t equals 0, v is 12,000. Well, let's tidy this up a little bit first of all. So I've got minus 1 over v equals minus kt plus c. When t equals 0, v equals 12,000. So that means that c, that'll become 0, will be minus 1 over 12,000. Right, let's have a look at what we're aiming for. We're aiming for v equals 12,000 at plus 1, where a is a constant. Okay, so putting the c back in there, hence minus 1 over v equals minus kt so I'm now going to manipulate this to get that, show that, which we're working with up there. Ugh. Doesn't look nice, does it? Right, so in order to deal with this, I need to do a bit of combining of fractions. So I can write this over here being all over 12,000 and then minus 12,000 kt minus 1. Okay, so that's your algebraic fractions that I've done there. I've basically said, well, okay, that's over 1. 1 goes into 12,000 times, so you multiply the top part by 12,000. 12,000 goes into 12,000 once. If I multiply throughout by -1, I get 1 over v equals 12,000 kt plus 1 over 12,000. So let's go back to what I'm trying to find. Well, I've got basically the same thing, but it's upside down. Hang on, let's see if I can get both bits at the same time. Because I've now got that over a single fraction and that over a single fraction, I can invert them both. So this I can just write as v equals 12,000 over 12,000 kt plus 1. So if you look at what I'm aiming for, I've got v equals 12,000 over, and instead of at plus 1, I've got 12,000 k. Well, 12,000 times a constant is another constant. So if we let 12,000 k be a, where a is a constant, then v equals 12,000 over at plus 1 as required. That's what they want. So it's a bit of faff dealing with that fraction to get it in the format that you need. There are other ways of manipulating that, but whichever way you do it, it's probably easier to do it by combining that pair of fractions first. Okay, we're not out of the woods yet. We've got a part C as well. The value of the car at the end of 2 years is 9,000. Find the value of the car at the end of 4 years. So part C. So I've got v equals, let's write this down again, 12,000 over at plus 1. And I know that when t is 2, v is 9,000. So that will allow me to work out what a is. So I got 9,000 equals 12,000 over 2a plus 1. So 9,000 2a plus 1 is 12,000. 2a plus 1 is 12,000 over 9,000. So just taking the multiply by 9,000 across. So 12,000 divided by 9,000 is 4/3. So 2a plus 1 is 4/3. 2a is 4/3 minus 1, which is 1/3. So a is a sixth. So we now know that a is a sixth, and we want to find the value of the car at the end of 4 years. So for t equals 4, v equals 12,000 divided by a is a sixth, t is 4, 4 over 6 plus 1. Okay, we can do this all in one go, or you can space it out, it's up to you. 12,000 on top, underneath we've got 4 over 6 plus 1, which gives us 7,200. So there you go, that's question 1. I'm going to be really brave here, and I'm not going to pause, I'm going to keep going. I'll probably regret it. We shall see. Question 2. The size n of the population of a small island may be modelled as a continuous variable At time t, the rate of increase of n is directly proportional to the value of n. Right, it's an increase, so it's going to be positive, and the rate of increase will be dn dt. So a will have dn dt is directly proportional to the value of n. Get rid of the proportionality by writing equals kn. That's it. That's your differential equation. Part B. Show that n equals a e to the kt, where a and k are constants. So I need to solve my differential equation by separating the variables. On the left hand side, I'm going to end up with 1 over n dn, and on the right hand side, k dt. 1 over n, when I integrate it, gives me the natural log, which I need to put in modulus until I can justify otherwise. N can't be negative because it's a population, so in this context, I don't need the modular symbols. So n is greater than 0 in the context of population, so I can write that as ln n equals kt plus c. I want it in the form n equals, so I have to take e. Okay, and we should be familiar with this little stunt now. That I can write as e to the kt times e to the c. E to the c is another constant, so I can write it like that as required. That's what we were looking for. Part C. Given that n equals 100 when t equals 2 and that n is 160 when t equals 12, show that k is that. Okay, so I've got two initial conditions because I've got two constants. So when n is 100 when t equals 2. So 100 equals a e to the 2t, and so if I call that equation 1, and I know that it's 160 when t is 12. So 160 equals a e to the 12t. So now what I want to do is, if I divide 2 by 1, so let's write these as fractions, I'm going to have 160 over 100 equals a e to the 12t divided by a e to the 2t. That means that the a's are going to cancel. 160 divided by 100 is 1.6, and when I divide expressions where the bases are the same, I subtract their powers. So I'm going to have 1.6 is e to the 12t take away 2t. 1.6 equals e to the 10t. Now to work out t, it's not t, is it? It's k. I'm putting the t in, so that's a k, a k, a k, a k, a k, a k, a k. I'm substituting in t, it's leaving me the constant k, which is what I'm going to work out. So now if I take natural logs, I get ln of 1.6 equals 10k. So k will be 1/10 ln of 1.6, and I want to show the k is 0.047. Hope I can. So, fraction button, 1 over 10, natural log 1.6, close bracket, 0.047. Let's go back to the question. Show that k equals that, correct the 3dp, yep. Then find the size of the population when t equals 20. So, to find the size of the population when t equals 20, I need to know what the constant a is. So, need a, oops. So in equation 1, I've got 100 equals a e to the 2k, which I now know is that. So if I store that, and I'll just store that in x, then a will be 100 over e to the 2 times 0.047, which is x for me, so fraction 100 on the top, underneath I've got e to the 2, and my 0.047 is in x, so I got that, which is 91.028. So therefore my formula with the constants in will be 91.028 e to the kt. K is 0.047 t. And we want to figure that out when t is 20. 91.028 e to 0.047 times 20. Right, so I've got the 0.047 stored as x. So if I store this as a different variable, so I'm going to store that in a. That didn't work. Store alpha a equals. Why is it not storing for me then? Store alpha b. Going mad here. Alpha b store. Okay, something weird going on there. So I'll just put that in straight away. So rather than store that, it's going to be that times e to the 20x equals 5.12. So find the size of the population. That doesn't look right at all, does it? When t equals 20. x is that 91.028 times shift e to the 20x. Yeah, it's come out now. So 233. Find the size of the population when t equals 20. Is going to be 233.03, etc., etc., which, because we're talking about a population, is going to round to the down whole number. So 233. I don't know what's going on with my calculator there. The maths was going fine, but I fell apart on my calculator. I'm sure you're screaming at me, it's this, you fool, it's this. Store alpha A. Or is it just store A? Ah, that's what it is. I didn't have to put the alpha in it. Right, anyway, it's wasting time. So that was question 2. I think what I will do is I will pause that and then I'll pick up 3 and 4, otherwise it's going to be quite a long video clip.